All right, last one. Here we're going to solve this quadratic equation using the quadratic formula. Again, what do we notice about it? It's not equal to 0. So I'm going to subtract 7 from both sides. Solves that problem. That makes that equal 0. I won't even think about subtracting these from each other because they're not alike. So that's, again, my left side. So here's what we're going to do. We're going to pull A, B, and C. I'm going to slow down really quick for you. A is 10. B, don't put -7. It's not -7. Notice how B is always attached to just the X or whatever variable you're using, but B doesn't exist, sorry, X doesn't exist right now, so therefore B doesn't exist. So if something doesn't exist, the value of it is 0. C is -7. C is the constant. C is what's always the number that's by itself. So again, there's nothing that we could do, and if some people put B as -7, they are undoubtedly going to get the wrong answer. Okay, so A is 10, B is 0, C is -7. Again, I'm going to plug this into the quadratic formula, because again, my answer is not going to be this nice cookie cutter, clear number. It's going to be irrational. So I couldn't factor this, it just wouldn't go well. B is 0, which is nice because when I plug 0 into -b, it's still simply 0. 0 has no way of being negative or positive. So we'll take the element away of having to switch signs and all that stuff. Here I'm just going to now plug and chug the rest of the numbers. Literally what they are. Make sure you're plugging them into the correct spots. Sorry, left-handed. And right now I have 0 plus or minus 0 squared. That should be rather easy. When we do that, 3 numbers by each other. This one shouldn't be ever, anything new. That is -4 always, times 10, which is -40, times -7, which is positive 280. Because 2 out of the 3 numbers are in fact negative. The denominator now becomes 0. With 0 plus 280, 280. Okay. Speed this up, again with the factoring. I'm going to break apart 280 into this separate factor. I'm going to use 4 and 70. It's being that I'm not doing the factors in this one, guys. I'm choosing this set pair of factors as opposed to the many others because 4 has a perfect square. Like I could use 8 and 35, I could have 10 and 28. Those are all numbers that multiply into 280. Why am I not using them though? Because none of those numbers that I just said have perfect squares. So here's how, again, I'm going to rewrite 280, just so I can simplify this as much as possible. 280, new and improved, is 4 times 70. Why am I choosing 4? The whole point of that was because it has a perfect square. So the perfect square of 4, which I can yank out of the radical, it doesn't need to be there anymore, will be 2. 70 stays though. 70 is never going to come out of that radical no matter what we do. Okay, and like on that second one that the video has posted, this is not my final answer. You must simplify. They don't even have to remind you to simplify. You need to think of that on your own. So 70, totally off. No, we're going to do anything to it. It's under the radical. It's done. It's going to be 70 forever. 0, 2, and 20. We can lower them down. 0 is irrelevant in this place. I'm going to cross it out. We don't even need it. 2 and 20. Are they divisible by anything? Is 2 divisible by 2? You betcha. 20 divisible by 2? Yes. 2 divisible by 2 just simplifies down to 1, or I can put nothing there. I don't have to put a number at all. And 20 divisible by 2 is 10. So I'm going to write it up here. Sorry. My final answer is positive negative radical 70 over 10. If you want to put that 1 there, I don't care. That's 2 separate answers. Quadratic formula. Love it.